All right, so from this problem then, we determined that there was a limiting reactant here, calcium nitrate. And all of this was done yesterday just to find the limiting reactant. Okay? We won't be using any of that anymore after we find the limiting reactant. That's it. Just to find out which one of those is the limiting reactant. Okay. So now what we want to do is find the mass of solid product produced. So let's go back to the balanced equation. And notice that this is the solid product. Okay? It says so. That's where our driving force was. You know, that should be the easiest question you should have to answer is, what is the solid to be produced, right?
Right.
Okay. All right. So let's go through then and find the mass of solid that might be produced from this then. All right. So we can actually reuse some of what we did in this equation. Remember, you have to start with the given amount, not the calculated amount. Here's the calculated amount down here. We're not going to use the calculated amount of limiting reactant. We need to use the given amount of limiting reactant to start with.
Right.
So we put that 5 grams of calcium nitrate, CaNO3 2. All right. Now, in this problem, we calculated the molar mass of calcium nitrate already.
Right.
Folks, pay attention. You don't need to calculate molar mass again if you've already done it. Okay? So we're going to use this molar mass to build a new conversion unit. But in this case, the mass is going to go on the bottom here instead of how we put it on the top here. The reason we're putting on the bottom here is because this is the side of the equality statement that matches the units and species in the part of the problem that precedes it. Okay, so we want 164.088 grams calcium nitrate.
Yep.
That goes on the bottom, and the other side of the equality statement goes on the top. 1 mole of calcium nitrate. Okay? There we go. Now, we've already balanced the equation. We need now, since we're going from one species to another, in this problem it says what mass of solid will be produced. Okay, we're going from a starting species, this stuff right here, to the solid here. We're going from one species to another. The only way you can go from one species to another is to have we've got to have a molar ratio. We do need to cancel as we go. All right. So we can cancel this and that. One on the bottom, one on the top. We can cancel them both. We can cancel these two. Those species can be canceled. But now we need our molar ratio from the balanced equation. So we need to go from 3 moles of calcium nitrate, the coefficient 3 we're going to treat like moles, 3 moles of calcium nitrate. Okay, and what we're ending up with is calcium sulfate, 3 moles of calcium sulfate. Yes. Once you find a limiting reactant, every calculation after that will start with a limiting reactant. Okay? It's really important that you can find the limiting reactant because everything that follows, and there's 2 other mass-to-mass types of calculations we're going to do in this unit. And every time after you find the limiting reactant, to find the limiting reactant, it doesn't matter which of the 2 starting species you start with. But once you find the limiting reactant, every calculation after that starts with it. Okay? At least in this unit, in the material we're doing here. Okay?
You've done just 1 mole over 1 mole?
Yes. But I wouldn't recommend you do that. I recommend you get used to this because if you try to do that, you may forget that if it weren't 3 and 3, say it was 3 and 2, we're trying to find this, you'd forget to put down the 3 and 2. So please use the coefficients that are there. Okay? Trust me, I've been teaching this a long time and I've seen every mistake there is to make, just about.
How long?
I'm in my 11th year. Maybe it's a 12th year teaching. I started in 2000.
You're looking young.
Thank you very much.
11 years ago, I was like 6 years old. It's freaking crazy.
Yes, and we've been working, building up to being a better teacher every year until just to get ready for you to be here. Okay.
Damn.
There you go. All right. So now we cancel as we go. Woo! Okay, and now we're ready to do the conversion from moles to mass. Here. For that, we're going to need a molar mass calculation.
Yep.
All right, now, turns out I've already done that. Okay. Some of you made some mistakes on this. So let's see if we can try to figure out where the mistakes are. First of all, you got to have your formula written correctly. I noticed somebody did like 2 sulfurs. I don't know where you got 2 sulfurs from here. I'm not sure. We had it written just like this yesterday. There's only 1 sulfur in the formula.
Yeah.
Let's see. I was going through it. Some of you, I don't know, maybe what you did is you used this coefficient out in front and said it was 3 calciums and 3 sulfurs and 12 oxygens, but you only use the elements that are in the actual formula here. Okay? You only use the elements that are in calcium sulfate. No, don't use the coefficients. Only these number of elements when you're calculating molar mass. Everybody got that? Any questions? All right, so now that we have that molar mass, move that up here and I'll put that right here. Okay, all right, so we've got a molar mass of 136.141 grams, but that doesn't need to go down here. I want to match the units and species of the preceding part of the problem, so I'm going to put this side of the equality statement on the bottom. I didn't see anybody that made that mistake. I'm just reinforcing that, hopefully. 136.141 grams calcium sulfate. Okay. There you go. I hear people whistling that little song, Cancel As You Go.
Yep, cancel.
Good. Very good. Very good. Very good. All right. All right. When we do the math, just a reminder, the way that you're going to put this in your calculator, trusty calculator.
Trusty.
You're going to multiply everything across the top, hit equals on your calculator keypad. Then you're going to hit the divide button and put in this number and hit equals. Hit the divide button, put this number in and hit equals. Okay? And then when you do that, you should have this answer.
4, 8, 6, 1, 6, 5, 2, 9. I get that.
I didn't get that answer.
Okay, then maybe you had an error in your calculator. Always do your math in your calculator twice.
Let me try again.
What?
Let me try again.
I
Okay.
think I did a logarithm.
All right, listen. Before you start doing that, let me finish up here for people who did. You got to underline all the insignificant digits, so you're going to look at only the measured numbers and calculated numbers to figure out the number of significant digits you need in a multiplication division problem. These ones here are not measured or calculated, and these 3s here are not measured or calculated. They're counted numbers, counted from the balanced equation. Okay? So we only look at this number, and this number right here. Okay? This one, and this one when we're trying to figure out what significant digits to use. And this one has the least digits. So we want 1, 2, 3 digits and underline everything else. Draw a line, and you get 4, well, let's use the black marker here. 4.15 grams of calcium sulfate. And there's your final answer. Yes?
I did it again. I got 4.148414.
Holy cow.
Holy cow.
Oh.
Holy cow. Mr. Tedder made an error? Really? God.
Did you do it twice, Mr. Tedder?
No, I did it once.
Oh.
I was kind of in a hurry.
Maybe because of the TI-82.
You still got the same answer.
Could be.
Could be.
It's not the same.
Yeah, see, Tommy has a light on his screen. You know he's right.
TI inspired. That's what it's at.
Yeah. Connor, I'm going to visit make a visit up here every once in a while. Man.
Oop, you know what? You're right. I must have hit a button wrong or something. So it should be 4.148414266. Is that right?
Yes, sir.
Okay. And yes, you're right. I did get the same answer, but you're right. This is actually slightly incorrect. Now, you know what? Here's the thing. If you do the math twice, you'll catch those things, right? So I probably should have done the math twice, but
It's okay. We forgive you.
I was in a hurry, so.
We forgive you, man.
Okay. I appreciate that.
No problem.
All right. All right, now let's go back to the big picture here a minute.
Let's do it.
There's the complete question. All right. So far, we have an awful lot of math here, okay? We started up here. We figured out a limiting reaction. It took all this stuff to get there. Okay, here's our molar mass calculations. Now we've done another mass to mass calculation to find the amount of this stuff that might be produced. Okay, now this is this species. Once you've calculated to this product, once you've calculated your way to this product, this is the theoretical yield. This is called the theoretical yield.
How do you spell that?
Well,
theoretical. E-T-I-C-A-L.
Theoretical yield. Okay,
Y-E-L-D.
that's your theoretical yield.
Get it?
Yeah, I got it.
Alright, good.
solid?
Well, it depends on what's being asked for in the problem. In this case, I did ask for the solid, yes. And most of the time, that's what we'll do in here. But you can't guarantee that because sometimes you're looking for gas.
What's the definition for theoretical yield?
Theoretical yield is the maximum amount of product that could theoretically be produced. The maximum amount of product that could theoretically be produced.
Say that again.
The maximum amount of product that could theoretically be produced.
That first part.
Theoretical yield is the maximum amount of product that could theoretically be produced. Okay? Now, in reality, you can never actually get this amount. So this is the top. Okay? It's the cutoff. If you get more than 4.15 grams when you measure the amount of product, something went wrong. Now maybe you've got some side products in there that you didn't account for. All kinds of things could happen. But generally speaking, if you've got more than this amount, something ain't quite right. Okay?
Can you keep that up there for another second?
One.
Yep.
Oh, done.
Yeah.
All right. Now, so what I've done here, remember I started out with one part of the problem here. Okay? Then we added another question to it. And we asked you what mass of solid product could be produced. Okay? Now I want to ask another question. Since we can never reach this, if you were to actually do this process in a lab, you'd never be able to, you should not be able to get 4.15 grams. It should be something less than that. So let's say you did get something less than that. Let's say that you collect 3.27 grams of this solid product. So the question then is, what is the... So this is your actual yield then. And we want to know what the percentage yield. What is the percentage yield?
Oh, man.
You'll divide, multiply by 100. You're absolutely right.
I didn't know how to do that.
Because percentages are always the part over the whole times 100.
Oh, yeah.
Right?
Right.
So we just take this number, divide by that number, and multiply by 100. Okay?
Why don't we take the 4.15 and divide it?
We take the actual yield, divide by the theoretical yield, take that answer and multiply by 100.
4.15 is the maximum, then that's going to be 100%. So you
Right.
divide it by.
There you go. He nailed it.
I agree.
Okay, so what percentage are you going to get? Anybody done it yet? So if you round it off to 3 digits, that becomes 78.8
Someone is banging.
78.8 when you round it off.
Affirmative, Joe Schroeder.
Is that 78 point?
78.8 yield, percent yield in calcium sulfate. Okay?